โอเคเสียงดังไหมอ่ะทำไมเสียงไม่ดังฮัลโหลฮัลโหลฮัลโหลฮัลโหลดังโอเค so very basic concurrency for beginner in Go computer can do things very quickly and if you can make them do anything that at the time job get finished even sooner modern computer have processors with many cores and spreading load across those core maximize performance and therefore speed of execution. Coding just multi-threaded code worked hard until Go came along and ruined it by making it so easy. In this article, we'll be explore the word Go keyword, a common gotcha when writing concurrent code, how to use the sync with group, the make sure to make sure our program doesn't terminate prematurely. What kind of impact concurrent code can have on performance? How making code ability. The Go keyword. To make a function run in the background. So this function main do something, become to function main go do something. Now, do something will be run in something, become to function main go do something. Now, do something will be run in background in a Go routine. If you want to play along with this article, but don't have your Go environment set up yet, you can always use the Go playground over at http://play.golang.org. Simple example. Let's explore this in little more detail and look at some common gotcha that can trip us up. Okay, script. Okay, to run this code, save it into a file called one.go. Open a command line and do go run one.go. Executing the above code will produce the following output. Start, do something, and it's predictable because everything happens in the order in which we have written it. Now let's make the do something function run in the background by modifying the main function. Okay, we are put the keyword go in front of do something called function. I really love that at concurrency in Go take only 3 key places G, O, and a space. Running this code now probably produce the following output: start, end. Oh no! What happened? And why only? Probably. In Go, when the main function exists, the program stops. In our above code, the background task doesn't get chance to do something before the program had ended. At which point all coroutines are terminated. To solve this, we could add a sleep operation at the bottom of our main function with time sleep, but that's not very nice solution because we don't know how long our do something function might need to run. Wet groups. The standard library gives us a package called scenes that has some great feature which we can use to solve this problem properly. A scene wet group is essentially a counter that we can increase in parentheses to indicate we want to wait for some things, and decrease to indicate things are done. Then we can tell code to wait until the wait group counter reaches 0, which would mean all things have finished. Update your code to look like this. Okay, script the code now. Some key points explain. Whoa. Okay. Note indicate that there is one thing to wait for. Wait indicate that code should block until wait group count reaches 0. Done indicate that one thing had finished. Notice that we don't ever create new wait group. This is because it is default 0 state. The state you get just okay, I don't understand. Come again. Notice that we don't ever create a new wait group. This is because in its default 0 state, the state you get just by defining it. Wait group is ready to use. Check it out wait group document for more about how to use them. Now rerun your code and you will probably see the following output. What with the probably talk when we are go to run code concurrently, we can't tell it exactly how and when to run this instruction. So it introduces some unpredictability. in our code. As long as you understand this is not a problem, and we can use things like word group object to introduce synchronization point between our code routine. If we move our word group instruction to above the line where we write in, we can be sure that things happen in the order in which we intend, but then there wouldn't be much point in running the code in the background, since we would just be writing in our main code routine anyway. How quickly we can do multiplication table. Create a new file called times go with the following this code. Okay. The print are specifically. How long does it take on the Linux system? Running command prefix by time command will tell us how long our code took to execute. In my case, it's just over 13 seconds. 13 seconds to do things kind of work embarrassing. If it were not for our time sleep instruction, but remember, it is just to simulate some resource-intensive task. Multiplying concurrency going to make code run concurrently to see if we can speed things up. Update this code like this, okay? As we did before, we have made the time stable function run concurrently and use a web group to make sure our program doesn't end before all calculations have finished. These times, we have the wait add function called inside the for loop. This is more common and allow us to calculate the timetable for variable number of things. Running the code with time command show us the impact that making our code run concurrently has had. We have gone from over 13 seconds to just under 1.5 seconds. Your results may differ, but they will be significantly improved. The order is confusing. Taking a closer look at the output reveals again that the order the instructions get executed in is unpredictable. Every thought we are counting sensibly upward. The order the operation actually occur variance. This is because each coroutine run at its own place, depending on things out of the control. like other things going on in the processor at the time. If we care about the order, we would need to use Go in-built channel to send data safely across the Go routine. But that is out of scope for this article. Conclusion: we saw that making code run concurrently in Go is as easy as 3 key plays, and provided we are careful about how that behaves, we can get some pretty staggering results. Next, you should learn about channel. Thank you.